If you think about the society benefits of having people being able to fly around the world, it means that we understand other people's points of view. It enriches all our cultures. However, people are much more savvy about the need to address climate change. My name's Paul Ticehurst. I'm a Senior Business Development Manager working within the Catalyst Technologies team. So the mission of JM's Catalyst Technologies team is to help our customers to decarbonise their technologies. The challenge around decarbonising the aviation industry is really the physics of flying. It's one of the most energy intensive things that we do. If you think about the amount of batteries you would need to have in a plane, just the weight, it's just never going to take off. There is a place for hydrogen at some point. However, there are still challenges associated with that. When you think about sustainable aviation fuel, you're looking at a fuel that contributes typically 70% less carbon dioxide versus normal aviation fuel.
I'm Emma Gledhill and I'm a Principal Researcher at Johnson Matthey. The feedstocks used for producing sustainable aviation fuel could be from biomass or domestic household waste, which would otherwise be going straight into landfill, producing copious amounts of methane. With traditional aviation fuel, the carbon source is coming from crude oil, or it could even be coming from coal. With the sustainable aviation fuel, it's coming from household waste. We're taking it and giving it a purpose.
The airlines are really very positive around sustainable aviation fuel. They can continue with the same fleets and they can use all the same infrastructure. So if you think about airports, they're all based around having a liquid hydrocarbon fuel. So you're making a minimal change to that whole infrastructure. It's a similar fuel used in the same way.
Here in the R&D Centre at Stockton, we're always looking to improve the production process of sustainable aviation fuel. We use the customer's chemical processes and repeat that here in the pilot plant, so we can then continuously support the customer to ensure that what they're doing is optimal for the catalyst. The Fulcrum Sierra project is the world's first commercial sustainable aviation fuel production plant. It's based in Reno, in Nevada in the US. It takes waste material that would normally end up in landfill and turns it into syngas. This is then passed through Johnson Matthey and BP's FT-CANS technology to create a mixture of long-chain hydrocarbons or waxes, and that's then processed into sustainable aviation fuel. Johnson Matthey and BP have been working very hard to produce a very effective Fischer-Tropsch catalyst. It is cobalt-based and it's on a very robust support. It produces very high-quality Syncrude or Fischer-Tropsch wax, which is then what's used to be upgraded to produce your sustainable aviation fuel.
We need to increase the amount of sustainable aviation fuel that's available in the market. What we need to see now is the investments coming in, and as soon as they come in, Johnson Matthey is ready. There's no challenge with scaling up our technology to many times the size of the Fulcrum Sierra plant.
I think it's really exciting to be working on a project such as this. We have a long way to go, but it feels really exciting to be part of that transition to a more sustainable future.
When I think about my job, why am I proud to be doing it? What inspires me? Well, if I think about my children, what am I going to leave for them as a legacy? And it would be great to be able to say, I made a difference, I improved the situation. Climate change has a less impact because of what I've done. I'm really proud of the work that we're doing in this area. It's one of the ways that we're catalysing the net zero transition.